Hello guys, welcome to today's class where we're looking at another question on combination method. In today's class we'll be looking at how we can apply the combination method to solve questions that are actually having the negative power. That is, when a particular value that are combined together by addition and then are squared, that is, are raised to a certain exponent or power, and then we are asked to expand. But then this power is a negative value, that is a negative integer. How do we now expand? Using the idea of combination. Remember I said for combination works with almost any power. So almost any power, any state it is, be it fraction, negative integer, positive integer, the combination method will work to actually expand it. So let's look at this. Please follow me through. Now we have this question here, example 3. We have, using combination method, expand 2x plus y raised to the power minus 1 to the third term in descending powers of x. Now, first of all, we have 2x, we have 2x plus y, all raised to the power minus 1, and then we're expanding this in descending powers of x. Now, from combination, you remember that when we say we have n combination r, we said our n must always be greater than our r in that case. But now, in using combination method to solve binomial expansion or binomial theorem, there are some adaptations we need to take in that mathematically, that is theoretically might not be possible, but then for the sake of mathematics, we just need to apply those principles in solving. Now, it is wrong for your n, in quotes, it is wrong for your n to be greater than r. That is, your value up to be greater than your value in the subscript position. But in this case, we'll be using something of that idea to actually be able to simplify whatever we have here and expand it effectively. So now, the total power here is minus 1. We'll be taking that as our n, despite all odds. So we have minus 1, combination 0. Then we have our 2x, the first value, taking all of the power, which is minus 1, and then the second value taking 0. So I'm still going through the same process. This is total power, we take it there. The next thing, we know from minus 1 combination 0, we can move towards minus 1 combination 1. But remember, in this question, we're giving a particular condition that because when we have a power in negative values, there is no limit to how much we can keep on expanding. So there is no particular number of terms that we need to expand to. So in a case where you are given like this one now, we are told to expand it to the third term in descending powers of x. As we know from here, the x will just keep on reducing. So this is the right order. But it said the third term, that means this is the first term. We take one more term here, and then we take one more term, and then we stop there. Because we can actually keep on going on and on and on. Because there is no particular limit. With the fact that our power here is a negative power or a fractional power. Once your power is not a positive integer, then there is no limit to how much you can keep on expanding it. So in this case, I'll be stopping at the third term. This is the second term I want to expand now. You have minus 1, combination 1. Remember, how to get the next term, we remove 1 from the 2x, from the power of 2x. So we have 2x raised to the power minus 1. That is, we remove 1 from this power here. Now, the one that I have removed from here, we add it to our y, to the power of y. So we have y raised to the power 0 plus 1. Then for the third term here will be minus 1 combination 2 now. This one will be 2x raised to the power minus 1 minus 2. Minus 1 again from the previous one. So we have here, our y will now be 0 plus 2. We'll be having 0 plus 2 here. And now we can simplify. So we know this one now will be giving us, from here we can actually say this is what? This is minus 1 combination 0. We know this is, from our knowledge of factorial or combination, we know this is minus 1 factorial over minus 1 minus 0 factorial, 0 factorial. And then we can simplify 2x raised to the power minus 1 as 2x raised to the power minus 1. Then we know y raised to the power 0 is 1. We can move on. We go to the next one. We have minus 1 factorial over minus 1 minus 1. With our knowledge of combination, 1 factorial. Then we know this is what 2x raised to power minus 2. And then we have y raised to power 1. Moving on, we have minus 1 factorial over minus 1 minus 2 factorial, 2 factorial. Where we have 2x raised to power minus 3. And then we have y raised to power 2. We keep on simplifying. From here, we know this will give us minus 1 factorial over minus 1 factorial times 1. As we know, 0 factorial is what is 1. We know this is 1 over 2x from our knowledge of indices plus the same thing we do here. We can keep subtracting from our knowledge of factorial. We can see minus 1 times minus 1 minus 1 factorial. We stop here so as to cancel with the 1 under. We know 1 factorial is 1. See, this one cancels this. I'll be left with 2x raised to power minus 2y plus the same thing I'll do here. I'll have minus 1 minus 1 minus 1, then minus 1 minus 2 factorial, so that I can cancel the similar one beneath. So here I'll be having, this is y squared, this one will be 2x, y over 2x all raised to power 3, which I can also express this one in that form. I can also say this is y over 2x raised to power 2 from our knowledge of indices. From here, I know this cancels this, so I'll be left with 1 over 2x plus, I'll be left with minus 1 here, so that will be minus 1 times y. I will have minus y over 2 squared, 4, then x squared. Moving on, simplifying this, I know this will cancel this. I'll be left with minus 1 times minus 2 over 2, then y squared over 2 raised to power 3 is 8, x raised to power 3 remains this, and then from here I'll be having 1 over 2x plus and minus here gives me minus over y over 4x squared minus 1 times minus 2 here gives me 2. 2 divided by 2 cancels out, and then I'll have plus y squared over 8x cubed. So this will be my final answer. But we should note that there can be more terms simplified here. So we need to, hence the need for the ellipsis to show that it can be continued.